Okay, guys, for this problem, we're going to be filling out this chart. You'll need to know how to use the basic isotope symbology. That's this basic symbol that I've shown you here on the screen. X would be the atomic symbol for whatever the symbol you're looking at is. The Z would be the atomic number. A would be the mass number, and where there's a plus and minus, that's where you would write a charge if there was one. Remember that the mass number A is always the sum of the number of protons plus the number of neutrons. So if you have the atomic number A and you know the atomic number Z, you can subtract Z from A, and that'll get you the number of neutrons. Now, let's take a look at the chart here. All right, so in the first line of the chart, we're given 12 protons, 13 neutrons, 12 electrons. And so because we're given 12 protons, we know that it's magnesium. If I add up the protons and the neutrons, then I can get 25 for the mass number. And so filling out the symbol, I know that the symbol is magnesium 25 over 12. And since the number of protons and electrons are the same, there's no charge. Okay, moving on. I've got calcium 42. That 42 next to the calcium tells me what the isotope is. So in other words, 42 is the mass number. And since the name is calcium, I know the number of protons is 20. Again, I know the mass number is 42. Subtracting them, I get 22 to get the number of neutrons. And there's no charge on that. We need to know that you need some basic nomenclature in order to decide that calcium is not a charged species. So you do need to know the nomenclature of monatomic ions to complete this task, this chart 100%. So number of protons the same as the number of neutrons. And so putting the symbol together, I get Ca 42 over 20. All right, the next one is number of protons is 42. The number of electrons is 42. I know that it's going to be neutral. The number of protons tells me that it's molybdenum. So I'm going to write that down there. I can probably sort out the number of neutrons now because I am given the mass number of 80. 80 minus 42 equals 38. And then making the symbol MO 40 over 42. All right, so the next one, all I'm given is the symbol. So I'm going to go ahead and fill out the things that I can. I know that there are 14 protons and that the mass number is 26. I know that there's no charge, so the number of electrons are the same as the number of protons, that's 14. And then subtracting 14 from 26, I get 12, that's the number of neutrons. And so putting it all together, this is silicon. Okay, so the next one is cobalt 56, just like the one before. Since it's cobalt 56, I know the mass number. Since it's cobalt, I know the atomic number. And now if I can take a look at this, I also know that it's not charged. It doesn't have the nomenclature that would indicate it's an ion. So the number of electrons are the same as the number of protons, 27. And I can sort out the number of neutrons by subtracting 27 from 56. I get 29. So the symbol would be CO. It's 56 on top and 27 on the bottom. So in the next one, I'm given the number of neutrons, I'm given the number of electrons, and I'm given the mass number. So I have to figure out what it is by subtracting the number of neutrons from the mass number in order to get 82 as the number of protons. Now that I've got that, I can look at my periodic table, and I know that 82 is lead. Now, going a little bit further, I notice that the number of electrons and the number of protons are not the same. The number of electrons is less than the number of protons. So that means it has a positive charge. So this is Pb2 plus as the symbol. So that means it is the lead-2 ion. And of course, you're going to need to know ionic nomenclature for monatomic ions in order to be able to get a clear understanding of that. So if you don't know that, make sure you kind of go back and review that in your textbook or online. Finishing out the symbol, 174 on top, 82 on bottom. Next up, potassium ion. Because it's potassium, I know that it's 19 as for the number of protons. And because it's potassium ion, Again, from my nomenclature, I know that potassium will form a +1 ion. That means it's got one less electron. So it has 18 electrons, not 19 electrons like it would in the neutral substance. It's the ionic substance, so it has 18 electrons. I can also sort out the mass number by adding 19 and 20 together. Oops, so it's not 31, it's 39. And putting out the rest of the formula, it's K plus 39 over 15. Okay, so the next one up is going to be 15 protons, 18 electrons, 31 neutrons. So I can sort out that this is 16 neutrons. 31 minus 15 is 16. So because it's 15, I know that it's based on phosphorus, but because there's 3 more electrons than there are protons, I know that it has a -3. Again, from nomenclature, I know that this is phosphide. And the rest of the symbol would be then 31 and 15. All right, the next one, all I'm given is the symbol. That's the symbol U is for uranium. I know that the atomic number must be 92 from the symbol, and the mass number is 237. Subtracting 92 from 237, I get 145 for the number of neutrons, and there's no charge, so the number of electrons must be the same, 92. Okay, this is the iron 3 ion. I am given the mass number so that I can sort out exactly what isotope it is. Because it's iron, I know that there are 26 protons. And since it's the iron 3 ion, I know that it has a +3 charge. In order to have a +3 charge, you must have 3 less electrons than you do protons. So that means there's 23 electrons. And subtracting 26 from 55, I get the number of neutrons, 29. Okay, that's this one, guys.